Okay, so for this one, we're going to just complete the square twice. We'll put all the x stuff together and all the y stuff together, and we'll move that 21 to the other side. So let's write it all out. So I have x squared minus 12x plus blank plus y squared plus 16y plus blank equals, and when I move that 21 over, it'll be just a 21. And then I'll have plus blank, plus blank. Okay, so let's see what needs to go in those blanks here. So for this, I have, I want to do negative 12 divided by 2 is negative 6. And when I square that, I'm adding 36. So I'll add that to both sides. And then for the y, I have 16 here. So 16 over 2 is 8. 8 squared is 64. And we'll add that to both sides. Okay, and so then when I write this guy as a square, it's going to be x minus 6 quantity squared plus, and then this will be y plus 8 quantity squared, and equals 21 plus 36 plus 64. 21 plus 36 plus 64 is 121. And we know that that is 11 squared. So if I write this all out, I have x minus 6 squared plus y plus 8 squared equals 11 squared. And so the center here is going to be at 6, negative 8, and the radius is 11. Okay, so this one I want to write the equation of a circle in standard form with center at 2, negative 5. So we'll have x minus 2 squared plus x plus 5 squared equals, and then I want to do the radius squared. So how do I figure out the radius? Well, I know the center, and I know a point on my circle. So let me just draw a quick picture so you can kind of visualize this. So 2, negative 5, that's the center. And then the point 5, negative 1 is on the circle. So in other words, if I were to draw the circle, it would look something like that, right? And so what I need to do is find that distance between those 2 points. And so, if I think about that, I can just, it's really the hypotenuse of a right triangle, so I could do Pythagorean theorem to find that distance. So the distance squared is going to be the square root of the difference in the x's, so it's going to be 5 minus 2 squared plus the difference in the y's, so negative 5 plus 1 squared. And so that gives me d squared is equal to square root of, that's 3 squared plus 4 squared. And so that's going to be 25. Or sorry, d, not, okay, so sorry, all of these should just be a plain d, because I already did the square root, so those are just the d's, d's, d's. And maybe I should have made that r for the radius anyway, so I'll make those all r's. We'll call this the radius, the radius, the radius. Okay, so the radius is equal to square root of 25, so the radius is equal to 5. So then I'll have 5 squared here for my radius. Okay. Given that g of x is that and h of x is that, use composition of functions to determine if g and h are inverses. So what we want is that g composed with h of x is just the function x, the identity function, and that h composed with g of the function x is the identity function x. So we'll check out both ways. So if I do g composed with h of x, that is, that's g of h of x. So that's g of, what's h of x? H of x is x plus 3 over 7. So that's, I'm going to plug that into the function g. So it's going to be 7 times that thing, x plus 3 over 7, minus 3. So when I multiply 7 over 7, that makes 1, so that's going to go away. So I'll just have x plus 3 minus 3, which is just x. So that's one way. So that checks out. And then we'll try h composed with g of x. So that's h of g of x. So that's h of 7x minus 3. Well, if I plug 7x minus 3 into the function h, I'm going to plug that in for x. So I'll have 7x minus 3 plus 3 over 7, which is just 7x over 7, which is just x. So that checks out too. So I have both of these things. The next one, I have a one-to-one function. I want to find the inverse function. Write your answer in inverse function notation. So one thing you can do is we know that when we do an inverse, we're going to be switching our input and output. So we can go ahead and switch them. You've already switched the x and y. So I get 3x equals 2y minus 5. And then I want to solve for y. So plus 5. And then I can divide by 2. So I get y equals 3x plus 5 over 2. So that's my inverse. F inverse of x is equal to 3x plus 5 over 2. For the other one, we'll go over here. And so we have x equal the fifth root of 2y plus 3. If I switch my input and output, I can solve it for x. So x to the fifth equals 2y plus 3, subtract 3, and then divide by 2. So that's my f inverse of x, is x to the fifth minus 3 over 2. So that's that. Okay. The next one says Sally is investing $35,000 for her retirement. Okay. So she can invest 4.8 at simple interest for 20 years, or she can choose an option with 3.6% interest compounded continuously for 20 years. So which one results in more total interest? So let's do the simple interest first. So I know that the interest is equal to the principal times the rate times the time. So the principal here is $35,000 times the rate, which is 4.8%, times the amount of time for 20 years. So that's 33,600 in interest. Okay, and then for the next one, let's do, so we know that the amount that it's worth is P naught E to the RT. So we can find how much it's worth. In 20 years. Okay, so we can do P equals 35,000 E to the 0.048 times 20. Oh, sorry, it's not, it's 3.6%, excuse me. So let's do that 3.6%. There we go, 0.036, sorry. That's what she's doing for compounding continuously. Okay, so 36 times 20. So we get that her whole investment is worth $71,905.16. But that's including her principal. So if we just want interest, we can subtract off that the interest is that what it's worth minus our initial investment. So the interest is going to be $71,905.16 minus the original $35,000. And for that, we get $36,905.16. Okay, so if we compare the two, that was $33,000. This is $36,000. So the better option is the 3.6% compounded continuously earns the most interest. Okay. For the next one, suppose that $12,500 is invested at 5.5% for 8 years. What amount would that be if it were compounding annually, monthly, or quarterly? Okay, so let's do A first. Let me erase some things here. So if we start on A, we'll do A in red. Okay, so if we're compounding it annually, that's going to be, so in other words, the model we're going to use is P is equal to P naught times 1 plus R over N to the NT, where N is the number of times per year that you are compounding. So that's what we're going to use here. So if we go to A, we're compounding once a year. So we're doing P is equal to, what's my initial investment? $12,500. 1 plus, my rate is 5.5%. And I'm dividing by 1 here, so to the 1 times 8, so to the 8. So let's plug that in. So we get $19,183.58. Okay, if we compound monthly, that means we're compounding 12 times a year. So if we plug that in, one thing you might remember when you plug this in is to put parentheses around that exponent, because you want to raise it to the 48 power. And so I got 19,389.34 if we round up. Okay, and then the next one, so that was B. That was B. Whoops. There. And then C we'll do in green. So we're compounding quarterly, that's 4 times a year. Oh, yeah, sorry, we're raising, 12 times 4 is 48. What did I say earlier? 12 times 8? That's more than 48. Anyway, whatever. So we're going to divide by 4 this time. So I got 19,350.75. Okay. And then a farmer depreciates a $120,000 tractor. So in other words, he has a $120,000 tractor and its value is depreciating, right? He estimates that the resale value in $1,000 of the tractor T years after the purchase is 80% of its value from the previous years. So the resale value can be approximated by that. Find the resale value 5 years after the purchase. So V of 5, just plug it in. So it's $39,000. The farmer estimates that the cost to run the tractor is $18 an hour in labor, $36 an hour in fuel, and $22 an hour in overhead costs. Estimate the farmer's cost to run the tractor for the first year if he runs the tractor for a total of 800 hours. Okay, so the rate here is going to be 18 an hour plus 36 an hour plus 22 an hour. And we want to multiply all of that by 800 hours. So that's 60,800. So that's the amount that he is using for maintenance and repair and labor and fuel. And then also, he's going to have depreciation. So in 1 year, it's going to depreciate 20%. So 120,000 times 0.2, so he's losing 20%, is 24,000. Okay, so his total amount that he is running the tractor is going to be 24,000, which is the amount that it's depreciating, plus it's going to cost him 60,800 in labor, fuel, and overhead costs. If we add those two together, we get 84,800. So we want to convert to exponential form. Okay, so this down here is the base, 9. This is the exponent, squared equals 81. Okay, this one, the A is the base, C is the exponent, equals M. Convert to logarithmic form. So on this one, I could do log, the base is 2, the exponent's 5, and the 32 goes here. For this one, we can do log, the base is C, the exponent is, N, and then there's D. So in other words, C to what power equals D, and the power is in. Simplify using the basic properties of logs. Okay, so what are some basic properties? So we know that the natural log of e to the k is k. And we know that e to the natural log of k is k. Those are the inverse properties of e and natural log. And I know that log base a of a to the k is just k. And I know that a to the log base a of k is k. So these are the basic properties that we want to use. Here I can see that I have natural log of e to the y plus 4, so that's going to be equal to y plus 4. Here I have log base 2 of 2. Log base 2 of 2 is 1, because 2 to what power is 2? 2 to the second power is 2, right? This one goes to this one here. Log base 4 to the log base 4 of x squared is just going to be x squared. And log base 7 of 1. Oh, so I didn't put that as a basic property. So log base a of 1 is always 0, because a to the 0 is always 1. Anything raised to the 0 power is 1. And also natural log of 1 is 0. So this is 0. Okay, there's a formula for a pH. Represents the pH of a liquid. Find the pH of the following. So if the H plus is that, then I want to find the pH. So the pH is going to be negative log of that number. And so I just compute that. So negative log of 2 times 10 to the negative 13th. So I got 12.69 from my calculator, round to the nearest tenth, so 12.7. Okay, and then milk of magnesia, so the pH of that is going to be negative log of 4.1 times 10 to the negative 10th. So I'm just going to plug that into my calculator. Negative log of 4.1 times 10 to the negative 10th. And I got 9 point, if I round to the nearest 10th, 9.4. 9.4. Okay. On 68, I want to write this as sums and differences of logarithms. Okay, so I know the principle I need to use is going to be over here. I know that natural log of a times b is equal to natural log of a plus natural log of b. Natural log of a to the k is k natural log of a. Natural log of a divided by b is natural log of a minus natural log of b. So when I divide inside the natural log, it comes out as a difference. Okay, so if I look at these, the p is raised to the 4th power, the q is raised to the 4th power, the x is to the negative 3, and the m, again, is negative. So it's going to be natural log of, so I can write it 1/4 natural log of p plus 1/4 natural log of q minus 3 natural log of x. Now it's a minus because the x is on bottom. And then minus natural log of m. Again, that's supposed to be an m. Why did I write a b? It's a minus, again, because that m is in the denominator. It's like down here. So it comes out as a minus. Okay. So the next one, I want to write this as a thing. So if it's going to be the log. Okay, so since that 6 is positive, we'll have an x to the 6th on top. And since that 1/3 is negative, that means I'll have y to the 1/3 on bottom. And since that z, negative 2/3 is negative, I'll have z to the 2/3 on bottom. So there it is all together. Then I'm going to solve the following exponential equations. Okay, so first here, I want to subtract the 22 from both sides. So I'll get 8 to the 4x minus 1 is equal to 163 minus 22, 141. Okay, and then I can just take the natural log of both sides. Okay, and then I can pull that power down. And so I have 4x minus 1, natural log of 8, equals natural log of 141. So then I can divide that over, and I get 4x minus 1 equals natural log of 141 divided by natural log of 8. Now you might be tempted to simplify that, but let's just leave it just like it is for now. Then we're going to add 1. And then we can divide all that by 4. Or multiply by 1/4. Natural log of 8. And then plus 1. Whoops, the plus 1 needs to go inside the parentheses. You see here. Plus 1. Okay. And then I can get a decimal approximation for that. So we'll do a decimal approximation. So natural log of 141 divided by natural log of 8 plus 1, and all of that is divided by 4. So I got 0.844, 0.84, oh, 4 decimal places, 4496. So 4, let's see. So 450, 8450. Okay, the next one, B, let's do it over here. So I have 100 equals 700 e to the negative 0.2x. Okay, so first I'll divide both sides by 700. So I'll get 1/7 equals e to the negative 0.2x. Then I can take the natural log of both sides. And then I can use this property here to say that this right-hand side is just the negative 0.2x. And then I can divide by that. So x is equal to natural log of 1/7 divided by negative 0.2. And if we want a decimal approximation for that, I can plug it into my calculator. Natural log of 1/7 divided by negative 0.2. So I got 9.72955. So 296, if you round. Okay, next one, C, I'll work in red. So we have 9 to the x plus 5 equals 142. So I can take the natural log of both sides. Natural log of 9 to the x plus 5 is equal to natural log of 142. And again, we'll use this property here to say that this side is just going to be, sorry, we're not using that property. We're using this property here to say x plus 5 times natural log of 9 is equal to natural log of 142. Then I can divide that natural log of 9 over. 142 divided by natural log of 9. And again, you might be tempted to try to simplify that, but you can't. Just leave it alone. So x is equal to natural log of 142 divided by natural log of 9, and then minus 5. So let's get a decimal approximation for that one. So natural log of 142 divided by natural log of 9, and then minus 5. So I got negative 2.7445. Okay, so last one. Let me delete some of this, and we'll work it again. Okay, so I got 16 to the 3x minus 1 is equal to 64 to the x plus 2. Okay. So what I'm noticing is that 16 is a power of 4, and 64 is also a power of 4. What is 16? 16 is 4 squared. So that's 4 squared to the 3x minus 1. And what's 64? 64 is 4 cubed, right? 4 to the third is 64? Yeah. So that's 4 cubed is 64. So anyway, I get 4 to the, and when I multiply those powers, I get 6x minus 2 equals 4 to the, when I multiply this powers, I get 3x plus 6. So in other words, I can take the fourth log base 4 of both sides, and I'll get this equals this. And so I can go ahead and set those equal. So I get 6x minus 2 equals 3x plus 6. And so I can subtract 3x and add the 2. So I get 3x equals 6, 7, 8. So x is 8/3. And that is an exact answer. So do I have to round to 4 decimal places? I don't know. 8 divided by 3. So that's 2.66. There, if you round.